Hello everybody. Today I'm going to talk about tides. Tides are really interesting. When you come to the seashore, you must notice that ocean beaches are sometimes covered by water and sometimes they're not. So what are tides? Tides are the periodic rise and fall of the sea caused by the gravitational pull of the moon and the sun on the earth. When it is a high tides, the water level rises. When it is low tides, the water level drops, which leaves more lands exposed. What causes tides to occur? Is it gravity? The answer is yes. Gravity is the link between Earth, Moon, Sun, and the tides. But is it equal to the tidal force that causes tides? The answer is no. Why? In order to answer this question, first let's talk about gravity. What is gravity? Gravity is a field force. It is proportional to its masses and inversely proportional to the square of the distance. That means distance matters. Our Earth is a big sphere with a radius of about 6,371 kilometers. When we look at this picture, we can see some locations are closer to the moon and some locations are farther away. The gravitational force exerted by the moon is different by locations. Some parts get pulled more, while some parts are pulled less. So suppose the Earth is an ideal dot. Everywhere on the Earth the gravitational force are the same. Then there will be no tides. Because everywhere has been pulled away equally, there is no stretch. But in reality, the difference between the gravitational force at the center and the gravitational force elsewhere causes the stretch of the surface of our Earth. The causes of the tides is actually the difference of the gravity force exerted on the Earth. So what is tidal force? The tidal force can be viewed as the difference between the gravitational force at the center of the Earth and the gravitational force at any other location. Let's look at the picture here. The gravitational force here is bigger than the gravitational force at the center of the Earth because this point is closer to the moon. The gravitational force at this point is smaller than the gravitational force at the center of the Earth because this point is further away. The gravity here, when you compare it with the center, gives you a vertical component of the force down. And this point gives you the vertical component up. When we subtract the gravitational force at the center from the gravitational force at any other location, we get tidal force applied on the Earth like this. As you can see, the surface of the Earth is stretched this way and squished a bit this way. Now we know the difference of the gravity force caused the tides, but we also know tidal movements result mainly from the pull of the moon's gravity on the ocean. Why does the moon exert an even stronger tidal force than the sun? Even though the sun is further to the Earth than the moon, the gravity force between the sun and the Earth is approximately 175 times as large as the gravity force between the moon and the sun, because the sun is so much larger than the moon. However, when you compare the tidal forces, that is the difference of the gravity force in terms of different locations, the distance matters more. If we apply some math like calculus, we take derivative of force in terms of distance, we can get the tidal force is proportional to the masses and inversely proportional to the cube of the distance. With some calculation, we can get a ratio of the tidal force from the moon to the tidal force from the sun is 2.2. So in conclusion, the tidal force from the moon is 2.2 times as large as the tidal force from the sun. So the moon wins. 70% of the Earth is been covered by water. Compared with the surface of land, water is more flexible and it is easier to be stretched or squeezed. On the side of the Earth that is nearest to the moon, the water is pulled the most, creating an outward bulge, which is called the high tide. On the opposite side of the Earth, the water is pulled the least. Relative to the center of the Earth, the water is pulled to the opposite direction, which creates another outward bulge called the low tide. If you live on an ocean shore, you can experience 2 high tides and 2 low tides every day. But why does the rise and fall of the tides occur twice per day? It's because of the Earth's rotation. If the Earth was not rotated and the moon was fixed, then the bulges would remain in the same location on the Earth. Relative to the moon, the bulges stay fixed along the line connecting Earth and the moon. But the Earth rotates approximately every 24 hours. That means if now you're the closest to the moon, in 6 hours, you will move to where the low tides are occurring. And in another 6 hours, you will move to the furthest to the moon. This is where the low high tides are. And 6 hours later, you will be again in the low tide. And another 6 hours later, you're back to the closest to the moon, where the high tides occur. At last, let's add the effect of the sun on tides into it. We learned that the sun exerts a tidal force as well. It is about slightly half of the tidal force exerted by the moon. Though its effect is less than the moon, it is still significant. Depending on the positions of the moon and the sun relative to the Earth, the net tidal effect can be amplified or canceled out. During full and new moons, the sun and the moon are in line with the Earth, and the tidal effects add, causing the oceans to bulge a bit more than usual. This means high tides are a little higher and low tides are a little lower. These are called spring tides, and they occur twice a month. Turns out it has nothing to do with the season of the spring. When there is a first quarter or last quarter moon, the sun and the moon form a right angle at the Earth. The bulge of the ocean caused by the sun partially cancels out the bulge of the ocean caused by the moon. This generates moderate tides, known as neap tides. The high tides are a little lower, and the low tides are a little higher. This is the tide height in a month. As you can see, there are 2 neap tides and 2 spring tides in a month. The neap tides are moderate, with smaller amplitudes in this wavelength. And the spring tides have larger amplitude. That's all for the tides. This video is part of our group project. If you want to learn more, feel free to visit our Minecraft Science World for the ocean topic. And thanks for watching.